0, ignition.
Lika Guhatakorta is program scientist of one of NASA's most ambitious solar expeditions. Scheduled for launch in 2004, the Stereo mission will send twin spacecraft to view the Sun from 2 different vantage points. It will take a 3D look at our star and help us measure the speed and direction of a CME.
Stereo, for the first time, will be sending 2 spacecraft that will veer away from the Sun-Earth line to get 2 different perspectives on the Sun. And what that's going to give us is a stereoscopic 3-dimensional view of this stellar object for the very first time. And we'll see what truly are the shapes and sizes of these massive ejections that we see from the Sun.
Among the space relics in a NASA museum, Lika and her son play out the future mission.
For instance, Tristan, my son, represents the sun of our solar system, and the balloon he is blowing is a coronal mass ejection pointed in the Earth direction. I represent one of the Stereo spacecraft, which is in the leading orbit, and this spacecraft is going to view the coronal mass ejection from this angle. Let's go to the second position. This is the second position of another Stereo spacecraft, and we are going to view the coronal mass ejections from this angle. Scientists are going to combine these 2 views and actually produce a 3-dimensional image of the coronal mass ejection coming towards Earth for the very first time. And it's going to allow us to determine the speed of the coronal mass ejection, its magnetic field geometry, and its composition.
A CME builds on the face of the Sun. Stereo sees it's headed right for us.
3, 2, 1.
Traveling at over 1 million miles an hour, it aims for a head-on collision with Earth.
Tristan.
As this mom well knows, the Sun can sometimes be naughty. The cold, dark vastness of space is warmed and illuminated by stars. Some may be better behaved than our Sun, others more unruly. But our planet's fate is bound to our daytime star, for better or worse. We literally live inside the extended atmosphere of our Sun. So we must continue to study its moods.
The Sun is a star we live with, and in this technologically driven society, if we really don't understand the Sun-Earth connection, I think we are at a loss.
What we should be doing is to anticipate as much as we can potential effects. Then we should try to learn as much as we can about the Sun during this solar maximum and the Earth-space environment so we can plan for the next one.
This solar maximum is really very exciting for us. We've got the most spectacular observatory in space that we've ever had. And we have lots of observatories on the ground. We're going to be able to look at it this time and see what's going on in much better ways than we've ever been able to before.
I don't think scientists really fully understand yet the true nature of the Sun. It's one of those that the deeper you look, the more questions you come up with. And it's almost like this mystery. The deeper you probe, the more confusing and the more mysterious it becomes.
The Sun will continue to nourish our planet, rising, setting, drenching our land in light and warmth. But our star, the only star whose face we see, is temperamental. we are beginning to discover its real nature. The Inuit have long known their lives were bound to the sun. They embrace and celebrate their connection to the heavens. Could they know something we have long forgotten or tried to deny? Our lives dance to the rhythm of the sun. As we continue to explore our ever-changing star, we may start to see it in its true light.